Welcome to Enlightning. I'm so glad you're here. My name is Whitney Lee. I'm a developer advocate at VMware Tanzu, and today we're going to learn about Cortex from Friedrich. Friedrich, will you introduce yourself, please? Oh, you're still muted. Wait, you're still muted, friend. Ha ha.
Okay, my name is Friedrich Gonzalez. I'm a software engineer, 20 years of experience as an individual contributor. At observability, I've been the last 6 years working. I work at Adobe, the Adobe observability team. Kudos to them. Hi to them. They're probably watching this. Yeah, that's it.
That's awesome. My son works at Adobe. He's a front end engineer for the libraries panel there. So, yeah, small world. I'm so glad you can be here. You're a maintainer on the Cortex project. And like all of these episodes, part of the charm, is that I know nothing about these technologies before this episode. So if you also know nothing as a viewer, you're right there with me. We can learn from the very beginning. And Cortex especially is a very blank spot in my brain, and I'm anxious to write in some wonderful knowledge. So let me say hello to some folks who joined, some friends who are here. We have Kormaju's here. Hi, Kormaju. Welcome. Kormaju is known for their epic questions. They have great questions. Ravi's here again. Hello, Ravi. Thanks for being here. And Epic Tralala. So glad to have you. Thanks, friends. Let's do the thing. What do you say? Will you tell me?
Let's do it.
Let's do it. What was the world like before Cortex existed? Why did Cortex get created?
Wow, that's an interesting question. I mean, it's a question that goes back to 2016.
Oh,
2016, right?
okay.
2016 was when the project was created by
Okay.
the maintainers. It is an open source project, right? Community
Uh-huh.
backed. It's a CNCF project for
Love
most
it.
people. And when we talk about Cortex, we say Cortex is horizontally scalable, highly available, multi-tenant, long-term storage for metrics, right? So it's about metrics. That's what
Okay.
Cortex does. But what is the problem, right? So you ask.
Yeah.
So I think to be able to talk about Cortex, we have to explain that it's a multi-tenant Prometheus, right? So it's like, okay,
Uh-huh.
so Cortex is a multi-tenant Prometheus. Um, what is a multi-tenant? What is Prometheus, right? So I guess you already had some conversations of what Prometheus was, right? I think there was
Yes.
some. Yes. So we had there was a couple of talks. I watched some of the shows that,
Oh,
and one
nice.
of them was
Yeah.
about. So it was about Prometheus, right? So I think
Mm-hmm.
is this completely in line, I guess, with your show, right? So it was Prometheus, Thanos, and finally now Cortex.
Yep.
So yeah. So maybe let's talk a bit on. Right. Do we want to define Prometheus or
I
a
do
bit?
want to define Prometheus, but first I was trying to understand what the problem it was solving without bringing anything Cortex. Oh, so first we'll maybe talk about Prometheus, just like a quick definition, and then the shortcomings of Prometheus that Cortex is solving. Does that sound good?
Yeah.
Okay.
Yeah. See, I think that sounds like appropriate. Yeah.
Okay. So I'm gonna erase this, and then let's just say Prometheus. What is Prometheus? I'm listening.
Yeah. So Prometheus is another project,
Uh
CNCF
huh.
project. It's a place where you can store metrics, right? Store
Mm-hmm.
metrics, query metrics. So those four things, right? Store, query, generate alerts, and
It does
notifications.
Prometheus. Does Prometheus also collects the metrics too, right?
Yeah. So it collects metrics, but it also stores them, right, locally, right? So it's
Uh
about
huh.
storing metrics uh, and allows people to query metrics using PromQL. Um, collects, stores,
Um.
query,
The.
allows querying the
Uh huh.
metrics, right? And
Okay.
also generate alerts. You can generate alerts with Prometheus.
Okay.
That's one of these things. And the other thing is it allows you to notify users, right, when there's an alert, right? So it sends sends a message, a notification using Alert Manager. So that's some of the things that Prometheus does. That Prometheus does very well. Um,
Mm-hmm.
that's we're talking 2012 when Prometheus came to be. So it's a very long time project. People use it all over, and it's very very good, right? But
Mm-hmm.
uh, but what are the things that Prometheus doesn't do well, right? So
Uh-huh.
those ideas are really interesting, um, and I think what Prometheus doesn't do well is limited by a single node machine, right? And right, so Prometheus was created for a single machine, right? So you just
Okay.
run one process, um, and when you're running in a single machine, you have like CPU capacity, memory capacity, network throughput,
Mm-hmm.
that kind of thing, right? So yeah, that's Prometheus was never created to be multiple, right? Some people do it, right? Some
Uh-huh.
people like from multiple Prometheus.
Uh-huh.
But then you have the problem like, oh, this Prometheus scraping these metrics, this Prometheus scraping these old metrics, and you can have a forest of Prometheus running, right?
Uh-huh.
And your data is scattered around. Um,
Okay.
so that's kind of like the horizontal scalability of Prometheus, like how people do it.
So
And
the problem of running lots of different instances of Prometheus on different
yeah,
machines is
yeah,
that your data is all scattered. You don't have a unified way to query all of that data across
yeah.
machines.
And you also
Okay.
have to decide where to put the data. This application goes to this Prometheus, this goes to the other Prometheus. So you kind of make the
Okay.
decision um, locally, right? And that can
Uh-huh.
get pretty large, right? So when we're talking hundred or thousands of Prometheus,
Uh-huh.
you can become in a problem. So that's one of the problems with Prometheus. And um, what the other problem that Prometheus has is Prometheus is a process, right? When it restarts, it's not gathering metrics, right?
Mm-hmm.
So it doesn't have high availability, right? So and what it means for users, right, when you don't have a high availability is there's gaps, right, in your metrics. You see your metric,
Mm-hmm.
then your metric is 0, then it's back to the value. Say what happened here, right? You see the dashboard, and then
Mm-hmm.
right, so because that's exactly why high availability in Prometheus is a problem. So what most people do
So
in Prometheus, yeah, go ahead.
oh, and maybe you were about to answer what I was about to ask, which is it my understanding high availability in Prometheus, you just have two Prometheus instances both scrape the same data and then and somehow keep track of it from there. And you have two copies of that data but
Yeah,
they're
exactly. So you have two copies, but now you think about that, right? So now you're
uh-huh.
paying double the amount of memory. I mean,
Uh-huh.
you're using half the capacity. You're
Uh
using two
yeah.
times, and you're using half the capacity. So it's
Uh-huh.
not a really efficient way to do
Yeah.
it. So that's why people like separate, like they just have more Prometheus that do different things.
Uh-huh.
Um, and then right, so that's the problem in Prometheus, right? And also from Prometheus perspective, it's typically a problem that you're scraping multiple applications, right? This team has this application, this team has this other application, and if you have just one Prometheus, you're ingesting data for multiple teams, right? So
Mm-hmm.
what happens if one of the teams is sending more data than the other? Well,
Mm-hmm.
you have a noisy network, right? So you have a Prometheus getting
Mm.
data, and that can create problems also in Prometheus. So that's the lack of multi-tenancy in
Mm-hmm.
Prometheus. So that Prometheus doesn't do that well. Um, and the last thing I want to say that Prometheus doesn't do well, even though it's really amazing, I really like it. It certainly has a use case, a small use
Mm-hmm.
case. So for small number of metrics, of course. When you have a large number of metrics, and you
Mm-hmm.
want to be able to perform faster querying, you don't have a way to make it faster. Right? You just query data, Prometheus. Prometheus has to go to the disk, get the data out. So you can have like a very large disk to have all your data. But imagine that you have a year out of data. You couldn't get that really fast, right? So it's very slow. And Prometheus is very slow in terms of querying um, um, large amount of data.
Mm-hmm. Okay. So
Right.
occurring Large amounts of data, which large amounts of data is the name of the game with observability.
Yeah, lots amount of metrics. Definitely. Um, right. So the other thing also, and I want to mention this, is also, don't know where you want to put it, but when you have multiple Prometheus, right? You
Uh-huh.
just start up another Prometheus. It's not just starting another Prometheus. You have to monitor it. So every Prometheus, you have to find a way to monitor it, and you have to have alerts on it, right? So you want to know where is every Prometheus? Like, is every
Uh-huh.
Prometheus up or not? So you want to be able to all of your Prometheus. So if you have 1,000 Prometheus, you need to
Uh-huh.
know, you need to be alerted every time of those instances are down, or you need to alert
Uh-huh.
somebody about those instances.
Ironically, you need observability for your observability.
And it grows. It's like,
And it grows. So that was kind of related to being difficult to manage as a whole, maybe. Like you're
yeah,
managing different instances, and it's difficult to have a way to manage it as a whole.
yeah,
We have a question for you.
yeah.
Prometheus is an open source monitoring tool. Why can't we extend Cortex features in Prometheus? That's a great question. And we did a Thanos episode last week, and it got the exact same question for Thanos. Like, why is this a separate project and instead of just making Prometheus better so it doesn't have these problems?
Yeah, so I think I can answer that. When you design an open source software, right, you make your decisions, right, what your software is supposed to do, and the maintainers typically make the decision what gets implemented and what doesn't get implemented. So some of those features started to get implemented in Prometheus. I'm talking years ago, but in the
Mm-hmm.
end, it wasn't like there wasn't they didn't match all the use cases, right? So you didn't have, like, Prometheus was trying to solve the specific problem in a single machine, right?
Mm-hmm.
And not trying to solve. So they understood that that was a completely different problem. So
Uh-huh.
so Prometheus as a project solves that specific problem. And other projects like Thanos and Cortex, they actually use Prometheus as a library and solve the same problems. So even though you might think, why it doesn't contribute back, I think
Uh-huh.
probably what I need to explain is Cortex reuses Prometheus internally as a library. So
Uh-huh.
even some of the bugs that we fix in Cortex, we first fix in Prometheus because it's almost like a library
Ah.
to Cortex, and the same for Thanos. So I
Uh-huh.
think your question is very interesting, and the question, we do contribute it, but it's just under a different name. It just reuses the same thing, because not everybody wants to have a large platform, right? Not everybody
Yeah.
needs, all these problems that we're talking about.
Yeah. So to fix these things in Prometheus proper, like there are people who just want a single instance of Prometheus, and so
Yeah.
therefore you don't want to add all this extra functionality to those use cases,
Yeah.
um, and bulk it up if it's not being used. But that's a
Yeah.
great question, Cormac.
It's
Thank
it's a
you.
great question. Actually, there's been situations where people talk to me like about using Cortex, and there's a very small number of active series and very small number of metrics, and I'm like, why are you complicating your life with that? just just use Prometheus, right? It's
Yeah.
simple. You can touch it. And I think that's the use case is when it's small. Yeah, Prometheus is what you need. When you have a
Yeah.
large number of Prometheus, you need long-term storage, which you haven't talked yet. That was the other thing that Prometheus doesn't have, right? So, the large. I mean, we did mention it, right? So, large amount of data, being able to store large amount of data.
It does not have the ability to store a large amount of data, or does
I
it
mean,
doesn't have long-term storage, or is that this? It's kind of the same thing.
it's limited by the amount of disk that you can attach to it, which in itself is a problem, right? So, how much disk can you attach to it?
Okay.
Um, and not only that, imagine your disk gets corrupted, which can happen. So that's a problem. And then you lose all your data because the disk is corrupted, and then you have to think about backups. So yeah,
I
so that's kind of the problem.
I have storage limited by disk space is has Like when you run Prometheus, are you running it on the same machine that's also running your workloads, and it's getting the metrics from the workloads that are also running on that same machine, and then it's
Y-
that disk space that's limited?
You can or you cannot. At the end of the day, it's
Okay.
one machine. It's just one machine. It can
Okay.
be a different machine, but it's just one.
I'm just saying, isn't all storage in the world limited by disk space? Like, I don't quite understand what that means.
Yeah, yeah,
I guess once you tell me what Cortex does, then what Prometheus doesn't do will become more clear.
yeah.
Because
So because there's a limited capacity in each machine that you can have. I mean, now Amazon or Microsoft can give you very large machines,
uh-huh,
but there's always a limit, right?
uh-huh,
And not only
but
that, when you have a high number of disks, when your Prometheus restarts, it has to read all of that to restart. It's like I have
ah,
all of these available, so I need to make it available. So it's going to start reading all the data that you have to be able to expose it, and it's like quite a lot of data. So it's
okay.
going to take a while. So typically, when you have a Prometheus 32 gigabytes, something like that, 64 gigabytes memory, it takes about 5 minutes to start.
Okay.
So which
Okay.
is a lot without
Yeah.
metrics. Yeah.
Uh-huh. Would it be maybe better to say Prometheus doesn't have long-term storage?
It doesn't have.
Is that
Yeah.
the same kind of saying the same thing in a different way? No.
Uh,
What?
whatever you think is best. I think for me it's the same.
It's the same? Okay.
Yeah.
Because this still isn't sinking in for me.
Okay. Cool.
Um, long term makes sense. Maybe it doesn't export. Does it? Surely it exports somewhere, right? If you want to.
Yeah. Yeah. You're getting ahead. You're getting ahead.
I
But
am.
I'm just building the the suspense for it.
I love it. Okay, so this is great. I have a lot of context now of why Prometheus is good, but also how it might not be great for every use case, especially as we're getting into larger distributed systems and systems where data is critical. It cannot be lost, So now I'm ready for that definition of Cortex, I think. You feel like it's
Yeah,
time? Okay.
it is. It
Cortex is.
is. So Cortex is a multi-tenant, highly available Prometheus.
Okay, just that easy?
Yeah.
A multi-tenant, highly available Prometheus.
Long-term storage for Prometheus.
Oh.
Or you can say
Multi-tenant.
horizontally highly scalable. It's horizontally scalable, highly available, multi-tenant, long-term storage solution for metrics. Prometheus, whatever you prefer.
And horizontally
Scalable,
long-term storage
solution.
solution for metrics that builds on Prometheus.
Yeah.
I like that. All right.
I do want to
There's-
say, yeah,
Uh-huh.
I want to mention something here because it's specific to metrics, right? So most people are, in terms of signals, talking about signals, they think of this data, but it's just metrics. And metrics is a very specific telemetry signal. That means is a quantitative measurement of something, right? Something,
Uh-huh.
a value in time of something that happened.
To have a metric, you need a point in time and you need a number, right?
Exactly.
A numerical number. These
Yeah.
two things. Yeah.
It's not logs, it's not events, it's not traces. And I'm saying this because there's always that is that people get confusion with that.
For metrics.
It's just, and it's about known unknowns, right? So Prometheus is about known unknowns, and Cortex is the same, known unknowns. And that's why you want to have that kind of thing over a long period of time, right? Because you want to know, and there's something you want to know over a long period of time. That's why this thing about long-term storage so important for metrics. Maybe not so much for logs or some other signals, but for metrics it's really important because it's a known unknown. It's something that you really want to know for a long period of time, if that makes sense. And the other thing in this regard is metrics are very cost effective in compared to other signals. So that's why we use it, and that's why we want to have them in long-term storage. By the way, this about known unknowns is coming from the white paper. There was a white paper, open telemetry white paper, that was talking about that, and it calls out this specific thing about metrics. And this about metrics is not just Prometheus metrics; it's more like any kind of metrics. It's like that.
Okay. Metrics. So metrics are numerical data at a point in time. They're about known unknowns and they're cost effective.
Yeah. When used correctly.
Very
minding the cardinality. Minding the cardinality. I know somebody's, my when used correctly, of course.
That's so funny. Yes.
Okay.
Awesome.
Cool. So
there's a lot to unpack here. I have a feeling we have 4 sections here to talk about, right?
Yeah, let's start with I don't know. Let's start with horizontal scalable, which seems like the interesting part.
Oh, okay. In storytelling, you save the interesting part to the end and keep them hooked,
No, everything is interesting. But I think here's where we kind of introduce a bit of the architecture of Cortex, even though I'm not going to explain the whole thing because it has a lot of components. But let's talk about the most important components. The one that has the metrics initially, right? And these are an ingester, right? So we have an ingester. And there are 3 ingesters typically because we save the data in 3 locations, right?
Is this should I draw a picture?
Yeah.
Okay.
Just put a ingester or 3 ingesters there.
3. So
3 bubbles.
Okay. Do I want like machines that have the Prometheus instances? Maybe there are 3 Promethei?
No. This case
we're not worried about that yet.
Cortex internals. I'm going to explain why Cortex is highly available. Maybe later we can compare it to Prometheus, but I think
I'll start with 3, and then I can always erase this one. The picture becomes more. But so we have 3 ingesters.
Right. So right. So, and the reason why we have 3, and people might say, "Wow, that's a lot," right? So, all the data that comes into Cortex gets triplicated in the ingester, right? So we save, and this is done by made of consistent hashing in the distributors, which is another component. There's another component that sends data to these 3 ingesters, basically.
And it's called a distributor.
It's called a distributor, yeah. So distributor sends the data to each of these ingesters. Why 3? Well, we know, machines can die, ingesters can throughput can get nasty. We all learned that from Prometheus, right? The same that happens to Prometheus can happen to ingesters. But in this case, what we have is a way to, duplicate the data. When we receive the data, in the distributor, right? And that's what receives the data. And then you might ask, who sends this data? How do we scrape the data? Well, the surprise was that since the beginning, Cortex was tied to Prometheus. So the first client of Cortex was Prometheus. So Prometheus scraped the data and sent it to Cortex.
Okay, and that's
Yeah.
how it works now too.
Yes, but there's multiple clients now as well. There's no
Okay.
there's Prometheus, there's OpenTelemetry collectors, or there's applications. You can just from applications say data directed to Cortex.
Okay, so let's so Cortex receives data from the distributor, and it can one of three sources. And name the three sources.
Prometheus, OpenTelemetry collectors. I'm talking Cortex 2024, right?
Okay.
Because in history it used to be just Prometheus, but now things have changed, right? We have new agents, right? And one of them is collectors.
Uh-huh.
And and then we just
What's
on
the what's the third
another,
one?
it's just an application enable
Application. Oh, okay.
OTLP sender,
Instrumented, yeah.
OTLP instrumented application, for example. Yeah.
Yeah.
So you can point that to Cortex,
Uh-huh.
and in this case we read the distributor would send the data to each ingester. The nice thing about the distributor is that
And wait, you said it triplicate it makes 3 copies of the data? Okay.
yeah. So and then distributors are not just one, right? Because like we learned before, just one machine is always a problem. So the
Mm-hmm.
distributors are stateless. We can run as many distributors as we want. And the way they find the ingesters where to send the data is by using something that is called consistent hashing, right? Which I mentioned before.
Uh-huh.
Um, this is an algorithm that is made for that. And
Okay.
the nice thing about this algorithm is that it allows to add new components and rebalance, right? So you add another component, another ingester, and now the
Uh-huh.
data can be rebalanced to the new ingester.
Ah, okay.
Yeah.
So, I'm just going to put it stateless and scalable
Yeah.
to
Nice.
okay.
Yeah. Yeah. Right. So in the ingester, right? The
Uh-huh.
ingester, what does the ingester do? The ingester does the same that a Prometheus would do, right?
Uh-huh.
It's the same as a Prometheus in general, right? It just gets the data and stores it locally, right? The ingester has a local disk, right? But that disk is also limited, as we learned from Prometheus, right? So what we have is behind the ingesters, we have a block storage, an object storage. So we have S3, an S3 bucket that receives the data from the ingesters. So the ingesters, they compress the data every 2 hours, and every 2 hours they send it over to S3.
Okay. So, Cortex
And
ingester receives the data, stores it locally, periodically sent it to an S3 storage
yeah,
place.
yeah. So S3 is what does the solution of the long-term storage. We
So
don't
it
do
definitely
long-term storage in the ingesters.
okay. And it is always S3 or is it any object storage?
It can be any object storage. Yeah,
Okay.
Azure, any. I
And
think somebody was using Cloudflare. Yeah.
to object storage. I want to write it for those who don't. I just learned this last week that object storage is where it goes for longer term. So those two are kind of too long term. Is it long or just longer term?
Long-term storage. Just long-term
Okay.
storage.
Object storage. I have a question. When it sends the data to the longer term storage, does it wipe it from the node? Like it's not local anymore, or
Eventually,
is it
yes.
Eventually? Okay.
Yes, it does wipe it. Of course, that's the plan, right? Getting risk of the
It
data
seems.
locally. But
Yeah.
the thing is, and this is something that we learned, that was learned from the Cortex maintainers was that data in the ingesters is very fast because it's in memory, right? It's in
Uh-huh.
memory. Ingesters have the data, and query that data directly is very fast. So sending all the data over to S3 or to a
Uh-huh.
bulk storage is nice, but it's not as fast as locally. So you do keep the
Uh-huh.
last 12 hours in the ingesters because you want to make it fast for the last 12
Okay.
hours. And
Okay.
the data for after 12 hours, right, to give you a number, would be directly queried to S3, basically.
Okay. Kormashu has a question.
Go ahead.
Is the ingester in Cortex like a cache memory?
Yes, yes, in some degree, it works a bit like, but it also saves to disk. It does work like a cache, but it does save to disk. It works like Prometheus. Prometheus works in the same way that the last 2 hours are in memory, but
Mm-hmm.
after 2 hours, the data is on disk. Um, does that answer the question? Sorry.
Yes.
Yeah,
It,
you said, yeah.
yeah. Um, keep local data for about 12 hours. I imagine it's configurable
Yeah, it's good.
for fast querying. And so there's a moment there. One piece of data goes to 3 ingesters, and after 2 hours, it's also stored. Is it stored one place, or we have like 3 copies of it now in long-term storage?
Awesome question. Because it's real that it's 3 copies in the,
3.
because we need another component that makes it,
Okay.
that duplicates the data, and that is the
Ah.
compactor. There is another component that is
Okay.
only connected to S3 and is watching for those new blocks uploaded by the ingestors, and is
Mm-hmm.
combining them, downloading and combining them, deduplicating the data, basically.
Okay. Uh, this is this drawing is getting creative, and I'm here for it. Okay. So this is our object storage. It looks like a bucket because of S3 buckets.
Yeah.
And it's just one object storage place. So there's a moment there, and then all 3 ingestors are sending the same one piece of data to this object storage. But then we have the dedupe, the compactor. Is the compactor, is it reaching inside the object storage? Who's talking to what?
The compactor is only talking to the object storage.
Okay.
It only watches for new blocks and
Uh-huh.
compresses those blocks, like combines them, right? It says this data is duplicated, delete it. It's not needed.
So it's going inside the bucket and a compactor. All right, here. So we have 3 copies, and for a moment there's 6 copies because ingester ingests after 2 hours, sends 3 copies here, but still keeps for 10 hours, still keeps its copy locally. So
yeah, and data, right? So you can recover in the case of problems. You can always recover because you have the data duplicated, right? So it's a feature. Mm-hmm.
Can I ask you the thing I don't totally understand? So it's cool that you don't want to lose your metrics. I get it. But like metrics don't seem so important. Like if you lose like business data, PII, like that's terrible. Like but like metrics are metrics are metrics. You're just going to generate some more really fast. And like why are we taking so much effort to make sure we don't lose any metrics?
That's a great question. Actually, yes, some degree, some of the metrics are really not important.
Uh-huh.
But there are some metrics that are really important. So Cortex doesn't care about what kind of metrics you put in. It treats them all the same. So it treats them in a way that you can always recover. So that's kind of like the point. on this. The point on Cortex is about reliability. You're never going to see a gap in the dashboards like you would see with in other scenarios, right? Here, you can always trust the data. It's replicated and is there. So
Can
that's
you
why, yeah.
can you tell me an example of when metrics are so critical they can't be lost?
I think, for example, service level objectives for an
Okay.
application.
Okay.
Think, for
Okay.
example, uh, there's a couple. I mean, there's a lot of critical
Or I
metric
can
stuff.
okay,
Yeah.
I can see like if a big slowdown or an outage happens and you lose the metrics for that, you just lost the opportunity to improve your system. And I have another question about this situation. Um, this all happens, and now the compactor dedupes, so we're down to one. But now, isn't like HA, you never have just one copy of the data? Like, is
Oh,
this
yeah.
is object storage duplicated? I guess is
I
the
think,
question.
yeah. Okay. So I guess in this case, once the data is in S3, there's no mechanism currently to back that up, of course, because I think here the case is more like rely on the provider for that
Okay.
they're gonna I think
Okay.
S3 buckets have a nice tolerance for failure. Like they don't do that
Okay.
kind of thing that often.
Okay.
Like you're
Totally
not in that
convinced.
business. Yeah, so they do a good job in that part.
Okay.
It was, yeah.
We have a question from Kormaju. Can we change the time to copy the data to persistent storage? So like we're saying about every 2 hours it sends, all three ingesters send their data to object storage. Is that configurable?
Oh yes, it is configurable. But I would caution against it. Is the thing. And most of the people that think about changing that, because they're
Uh-huh.
thinking, I just want to save it faster. The thing is,
Uh-huh.
all these storage providers, they're more expensive the more queries you make to them. So this idea about storing every 2 hours is also about being cost effective. You're only
Okay.
sending requests every 2 hours. If you start sending requests, every 10 minutes or every minute, um, you're also going to have, a lot more requests, and it's going to be more expensive on the provider. So, yeah, because this is also something probably I'm hoping people are familiar, but the thing is, the storage is not that expensive. What is expensive is the request, the read request or the write request, typically
Oh.
to these systems. So that's why you want to have this system that only sends periodically. So yeah, it's not like I know people are like, oh, we just send to S3. Let's just use S3 for everything. Yeah, there's a cost effectiveness there.
So the compactor deduplicates the 3 copies, so there's only 1 copy left in object storage. It doesn't send it to a new object storage. I'm drawing stars to represent the pieces of data. We have 1 star, and then it becomes 3 blue stars, and then the 3 stars are now in object storage. And now the compactor makes it 1 star again, but in object storage, in the same object storage.
Yeah, I would have to
Okay.
say also, Compaxus does another step, and is that you have now one block every 2 hours, but then after a while, it start creating blocks, larger blocks, like blocks for 24
Ah,
hours, for example.
okay.
And then those blocks are even more compressed. So the compactor does this very good job of compressing the metrics in the object. So at the end, even the footprint is even smaller when the day finished.
Okay. I'm going to have to start higher. I got it. Versus object storage. So basically, the older data gets, the longer it takes to query it.
Yeah, that's normal. Yeah.
Okay. Well, I was thinking like, why wouldn't it be in big blocks in the first place? Presumably, as it gets into these bigger blocks, it takes longer to query. That seems to be the
Yeah,
trade-off.
it's configurable. I don't think anybody does it, but it's configurable. You could theoretically do any kind of blocks you need. Yeah.
Okay. We got Ganatak is here. Hello, Ganatak. Welcome. Yay, Prometheus. Cool, cool, cool. So the compactor works alongside object storage to do these things.
Yeah. So I'm gonna ask myself a question because just to finish the diagram.
Great.
So who queries the data, right? So we're talking about
Yes.
ingestion, right? I think this
Uh-huh.
this all of this is about ingesting the data, right? Getting
Mm-hmm.
the data in. But now we have to talk about how to get the data out, right? The
Mm-hmm.
query part that Prometheus does as well.
So I have a question about querying generally, and that is, does a UI have count as querying? Like if you're visualizing something, you're querying that data in order to make the visualization. Is it the same thing?
Yes, it's the
Okay.
same thing. Yeah.
Okay. And does Cortex do the visualization or just does querying and like pairs with the dashboard
Yeah. So
software
in
for it?
that sense, that's where it differs from Prometheus and also from Thanos. Doesn't have a UI. Cortex is just an API. So you can put in
Okay.
front of it a Grafana agent, a Grafana, or 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 there's also this tool now called Persis. But typically people just use Grafana, right? So you point a
Mm-hmm.
Grafana to Cortex, and you're able to query it like you would query a Prometheus, basically. And you could create the dashboards. It behaves exactly the same as a Prometheus would behave. It just for the user, there's no different experience in that sense. All the details that we're giving here for the normal
Mm-hmm.
user, they don't have to learn any of that. I think,
Okay.
yeah. So for the query layers, to finish that thought, I don't want
Mm-hmm.
to put it like we do have a lot of components. I don't know if we want to go into detail in each one of them, but for example, I do want to explain the first one, which is the querier. You can
Mm-hmm.
draw a querier, and that query is able to query block storage and also the ingesters, because that's something we mentioned, right? We said
Uh-huh.
we're going to query the ingesters for the last 12 hours, but we're also going to query block storage, long-term storage after 12 hours.
Querier.
Querier, yeah.
IER. Querier. So our querier does long-term queries, uh, queries ingesters for data that's less than 12 hours old. And queries object storage for data older than 12 hours. And it doesn't have a UI. It would work alongside some other UI technology.
Yeah.
Right? Which I think is great. Other people figured that out.
Yeah.
No need to do it here. No UI. So it's all like a CLI API.
So for most people, they just use Grafana, or some people build their own tooling. Yeah.
Cool.
So it does, like, if you want to draw the line, it's fine. I mean, if you think it's gonna get clouded results, but it just queries the object storage, right?
Yeah, I think the
And
lines will
and
be
the other thing,
confusing. Uh-huh.
yeah. So the other thing that query does is it has
There's more.
a caching layer as well. So you can and it's typically added, you can add a memcache or a Redis cache to it, so
Mm-hmm.
you can cache your queries, so that you
Nice.
don't have to query
The data again.
S3 bucket or the ingesters. It's just cache, and when you're using cache, you can go get below seconds query. So that's where the faster querying in Cortex come, in the caching layer, which is
Okay.
which is nice,
How long
right?
is data cached?
Oh, it's configurable. You can configure. Typically, though, what you do with it, there's a typical configuration in Cortex is that you define a timeout on the cache. So you want cache, but you want your cache fast. So if your cache is not responding on 400 milliseconds, you query the S3 bucket, right? Because it's taking too long for whatever reason. So your cache, the cache in Cortex is it has a specific configuration of being fast. It's not just that is there, but also that is, we kind of prioritize faster query for the tenants. So it tries to store everything basically, or whatever capacity you have assigned, um, and it does discard some of the data, of course, at times when it's older. And But yeah, that's kind of like one of the important features of the query layer and why it's important. Also, I should mention the query layer also horizontally scalable. Like we said, is stateless. Query is also stateless.
Mm.
You don't need a state in those components, because the state, like you said, is in the in the ring that we mentioned, that is able
Mm-hmm.
to find where the blocks are. The same ring that the ingester used that we talked about, consistent hashing, is the
Uh-huh.
same ring that the queries use to find where the blocks are.
It's called a hashing ring.
Yes, hashing ring. Yes.
This is, I think, the third time a hashing ring's come up, so I think I should probably learn what it is. I'm giving in. Or write it on the board at least. So at first I was like, a hashing ring seems complex enough that maybe for beginners we'll leave it out. But let's define hashing ring. Let me see. Yeah. So tell me the definition of a hashing ring, please.
Um, a hashing ring is an algorithm.
Uh-huh.
It's different, there are different implementations, right? The one that
Uh-huh.
Cortex has is the one that allows you to, like, when you get received data from distributors, it
Uh-huh.
allows to decide where to send the data. It's hash. There is a function says. So
Mm-hmm.
for example, you receive a metric that says has this metric name, it has these labels, and per those labels and those metrics, you
Uh-huh.
hash it, and that hash assign it to a specific ingester. And you say, oh yeah, there's this hash function, and then you say, I know where the ingester goes. And then the distributor is able to make that decision fast about where to send every metric that comes in. Um,
Okay.
and then there's also the next ingester, right? So the hashing ring, remember we talked about three ingesters. So it's also the hashing ring is also applied again and say, okay, give me another ingester, and then you get the other ingester. Um, and then that's how you get the three ingesters. The reason why that is important is because you're able to find where the metrics are, because you know that the solution to that hash function is always the same. Does
Mm-hmm.
that make sense?
Yeah.
Yeah.
Helps distributor and querier know which ingester is storing what data.
Yeah.
Helps. No. Kurmash has a question for you. How does the ingester identify the persistent storage? What kind of protocol or network between them gets configured? How secure is this connection?
Um, yeah. So the ingester has it configured already. So you configure the URL and also the authorization for the object storage. So it's already implemented in Cortex. You just have to say, for example, here's the name of the S3 bucket, and here's the keys to access that S3 bucket, and it uses the protocol for that. The protocol to access is HTTPS, but basically S3 protocol, which is block storage protocol, basically.
Excellent.
Yeah.
Okay, so let's revisit. We have our hashing ring now, and that makes sense to me. So let's revisit highly available. So it's highly available because it's stored 3 times, sometimes 6 times, and then so we got the highly available. It's horizontally scalable because these distributors are scalable because of the hash ring that we talked about.
Yeah.
So we got that. Long-term storage solution. It's long-term because of the way it works with object storage and eventually sends data. And multi-tenant is the thing we haven't really talked about yet.
Yeah.
Yeah. Did we cover the other 3 well enough, or is there more to say about?
I do want to say something regarding high availability. Because I do want to tie a bit down to something I said at the beginning, right? We said you have to monitor every Prometheus, right? You have to know where every Prometheus. And here, in this case, you can see that you don't have to do that anymore, right? Because you lose a node, it's part of the business. You don't care about it. You have a node and you don't care about it, right?
Okay.
So when you monitor Cortex, you monitor the entire Cortex. You don't monitor of course, if you have a number of nodes that is going down, I mean, you definitely have to pay attention, but you look more in terms of percentages, right? You don't look more like one single ingester is down. You don't even have to alert anybody about it, right? It's just normal business.
Okay.
So yeah, that's part of the high availability of it, like the ability to not care about things coming up and down.
I think it's so smart when failure is incorporated into the design in the first place instead of the failure being something that you have to deal with separately.
Yeah. And there's another thing here in high availability that I want to mention is there's also support in Cortex for availability zones, right? So and there's a concept in cloud that when you request a machine is in a specific availability zone. And so typically those providers ask you to deploy your machines in multiple availability zones, right? So Cortex can be defined, can be configured to tolerate single availability zones failure, which is typically what they say, right? They say they can lose the whole data center. And Cortex is able to tolerate that, to tolerate losing an entire availability zone. So in that sense, I'm saying you can lose a whole availability zone, and you don't even need to be alerted because you won't have any downtime because of the way the things are configured.
Cortex can lose, like ingesters or distributors can fail, no big deal. It recovers without you even doing anything. Any of these. Yeah?
I didn't hear you. Can you repeat?
The ingester or the distributor, or really any of these components can fail, and it's no big deal at all. Like you don't even have to perform any remediation.
You can lose the ingesters are really good. Let me maybe make this clear. You losing more than one ingester is a problem, right?
Okay.
But it can always rehash, right? And that's the thing with monitoring system is that you need to recover. You need to recover fast when you're having downtime, right? So, and that is something that can be achieved with Cortex. Losing one node in in the hash ring is
Uh-huh.
you don't need to be alerted. Losing more than
Uh,
one node when you have a replication factor of 3 is already
mm-hmm.
a problem, but can be solved as well. Like it's a problem because you lose more data. You still have like that little that little ingester that has all your data. If you lose 3 ingestors, then now you're in trouble because you probably lost some data, right?
Okay.
Um,
Yeah.
because you know that's the way it works. I mean, we can't be perfect, right? Perfect would be impossible to make.
Yeah. Inexpensive.
Yeah,
um, so in terms of high availability, a single ingester failure can recover easily without manual remediation. And then also,
yeah,
it can be configured to tolerate losing an entire availability zone too, in terms of geo
yeah,
replication. Cool.
yeah,
I
yeah,
have a question, and maybe I want to hear about. I have 2 questions right now. One is I want to know more about the multi-tenant situation, and the second
yeah.
thing is I think I would like an explicit explanation of what differentiates this from Thanos, because a lot of there seems like there's a lot of overlap. Yeah.
Yeah.
Okay. So it's your
Let's
choice
do
where
it.
we go next. Those are the 2
No,
things I want to talk about now.
let's do both. Let's start with
Okay.
multi-tenancy, right?
Okay.
Multi-tenancy, like I said, is interesting to solve the noisy neighbor, right?
Uh
So
huh.
if you have team that is sending more data than others, you want to put them in different places so that one tenant doesn't get affected if the other one is not doing the right things. So the way that works in Cortex is that every request that comes in Cortex, and this is from 8 years ago, this is not something that was implemented recently. This is from the
Okay.
beginning. Every
Okay.
request that we get in Cortex is identified with a header, and that header identifies the tenant. So it when a request comes in distributors and goes to ingesters and then goes to S3, every along the way, there's always an identification of the tenant. Um,
Okay.
so things are saved in the ingesters in different TSDB using the same process, but in different locations. So multi-tenancy is all across all the components configured.
So at some point, identity is attached to the data that's being collected.
Yeah. Cortex
So
doesn't work if you don't tell which tenant it is about,
so the
basically.
distributor
So
presumably adds identity to data. Okay.
yeah, no, the distributor
No.
receives that. Like you could create typically what people do, they put a proxy in front of the distributor that does that, like sets up the header, like has some
Okay.
authentication, and they receive the request and it provides the tenant to the distributor, right? But
Okay.
yeah, and we also have a experimental component that does that too. Cortex also we have the auth gateway that does that. It's not used at all. It's something very recent. We did like a year ago, something like that.
Okay.
But that component is supposed to do that, right? Receive the request, create the header, and send it to the distributor.
So, as part of setting up Cortex, you have to set up a proxy or maybe use this experimental thing,
Yeah,
something that's going to attach identity to your
yeah,
metrics data.
yeah,
And then in whatever format Cortex wants it in. And now
yeah.
Cortex. Okay.
Yeah, see, if you install Cortex Helm chart, it even has an
Uh-huh.
Nginx that does that for you.
Okay.
There's an Nginx configure to do that. It's very
Okay.
basic, right? It's not the most best thing though in the world, but it does the job. I mean, if you have a
Uh-huh.
small number of ingesters, definitely works.
Okay. And then once that identity is attached to metrics, now Cortex can implement limits.
Yes, definitely. Exactly. I think you're
Uh huh.
trying to. Yeah, it does that. It does also. So it's like all the path around all the services have
Uh huh.
that tenant ID,
Uh
and
huh.
using that tenant ID, operators can define limits,
Uh
ingestion
huh.
limits, right? So you don't want to send us that much data, and query limits, right? You say, oh, you're making a query too large. We're going to reject that query, right? So you can do that
Mm-hmm.
kind of thing in Cortex, and that's one of the nice features. Typically in Prometheus, when you send a very large query, you can omit, right? You can have it run out of memory, or when you send a lot of data, it can also run out of memory. So Cortex in that case doesn't run out of memory if you configure proper limits, right?
So query limits and ingestion limits.
Yeah, per tenant, because
Yeah.
yeah, like we do have also other limits that are for the entire cluster, but these are specific for tenants.
Okay. Let's see. Is there a way to also have isolation? Like if you don't want one team to see another team's metrics data?
That's by default, right? That's
Okay.
provided by what I said, right? Using the tenant ID, you can only query your data. You cannot
Uh-huh.
query other data. Like to query other data, you have to use a different header, right? And that is provided by default. Like Cortex doesn't do authorization, but it
Mm-hmm.
trusts that header, right? So you can design any kind of authentication authorization you want
Yeah.
for being able to look at the metrics, but Cortex is going to respect that. When once it gets the header, is not going to go outside of that header. You're not able to see any other metrics from other tenants.
Mm-hmm. That makes sense. That make like they're it'd be silly for Cortex to implement their own identity solution. Yeah. When it exists. It exists already and it's good.
Yeah.
Um, cool. So we have multi-tenancy in Cortex, which helps implement limits and isolation between teams, which is super cool. And then the question of Thanos versus Cortex. Like, what are the differentiating factors?
Yeah. Um, Thanos, right? So Thanos is a project that came. So Cortex started 2016. Thanos came in. I think it was the year after 2017 November.
Mm-hmm.
And it was both projects were running at the same time. They did different things in the time. I think at some point in time, I think it was around 2022, Cortex and Thanos began collaborating way more, right? To the point
Mm-hmm.
that Cortex introduced experimental block storage. So in
Mm-hmm.
that, and when that happened, Cortex used more Thanos. So
Mm-hmm.
Cortex 2024 it
Mm-hmm.
uses a lot of Thanos, right? It uses internally a lot of Thanos,
Mm.
and it contributes to Thanos a lot of the features. So some of the features that
Oh.
need to be fixed in Cortex are fixed first in Thanos. Um, and so where does that different? And I think where it differs is that Cortex was from the beginning just an API, right? You don't
Mm-hmm.
have sidecars, right? Like in Thanos, that you set
Mm-hmm.
up a sidecar that you can query. Cortex also doesn't do pull base, right? Like like a bit like the sidecar does. It's just
Mm-hmm.
Cortex is just receiving all the push from all the ingesters. Um, there's another feature that we don't yet have in Cortex that is downsampling. We don't have downsampling.
Mm-hmm.
But other than that, I think, and even downsampling can be implemented in Cortex. It's just never has found a way. Like I don't, the content maintainers haven't found a way to implement that. Like they need to pass some things to be able to implement that. But it's totally doable. Like in a sense, you could put every feature of Thanos in Cortex if you want it, because it's based on Thanos nowadays. To be honest.
So if I was maybe I have Prometheus, I'm starting to scale it up, I'm starting to hit these problems, and now I'm evaluating Cortex and Thanos. What use case is Cortex good for? Why would I choose Cortex?
Well, if you like, multi-tenancy in Thanos is not something. I think it's something that recently they got to implement to some
Uh-huh.
degree. There's some experimentals, but like Cortex from the beginning does that multi-tenancy, and
Okay.
those things about limits per tenants, those are Cortex things. The things
Okay.
that, for example, the rings, the way
Uh-huh.
that we handle the rings, the way that things are configured, those things are automatic, right? The hash ring is not something that you have to tweak. It's something you configure, like you configure a Cortex of 3 ingestors, and if you need more capacity, you just add more ingestors. It auto configures everything. In the case of Thanos, I think you have to configure everything, right? Just every time
Okay.
you have to tweak it, decide things. So I think Thanos is, in that sense, could, um, I would say, if you don't want to touch your Prometheus infrastructure, right? So you suppose
Mm-hmm.
you have a Prometheus deployment and you just put a sidecar everywhere, and previous infrastructure keeps working. Now you just have a sidecar that sends data over to Thanos, um, and and you can use Thanos for that, because it's
Okay.
like keeps your infrastructure untouched. With Cortex is like you just send data over, right? And it doesn't matter if you whatever you're using, right? You don't have to touch the infrastructure at all. Um,
So what I'm
I
hearing is Cortex is better with auto instrumentation. It's easier to set up, but Thanos is better.
auto scaling, more like auto scale, more
Auto
easy to
scaling.
scale. Yeah, for auto
Okay.
scale. Like at the end of the day, what I have is horizontal pot auto scaler that scales the ingestors as needed. Right, just you
Mm-hmm.
need more capacity. You're getting more metrics. I'm sitting here with you, and it's just add more, more pods, and we get more capacity. And you don't have
Okay.
to configure. You don't need to configure anything. It's all automatic. I mean, it's already
Uh-huh.
done. Um, right.
This is cool.
Yeah.
I'm having a very nice time.
Me too. Yeah.
Good.
I'm happy. I'm happy we went through all of this, and it's been what? I mean, time has fly.
It does.
Yeah.
It flies by. We still
Yeah.
have a little bit of information. If there's some sort of like takeaway you want to put down here, or the docs, or how to reach you, or
Yeah.
whatever.
So
What do
I
you want to
think
do with this
the
last bit of
final.
space? Yeah.
So I think probably the last piece I want to say is, there is a client view and there's an operational view, and I think
Okay.
whenever all these podcasts, we always talk about like the internals, and Cortex works like this and does that. For most people that use Cortex,
Mm-hmm.
they don't see any of this. For most people, it's just a Prometheus.
Ah.
For
Okay.
most people, is an API, right? You just query it, you push metrics over to it using remote writes,
Mm-hmm.
and we didn't talk about it, but you can modify rules in Cortex. So you can create recording rules, you can create alerts, just like you would in Prometheus. There's an
Okay.
API for that. There's a CLI tool that you can use to touch your rules there. So it's basically, as a user, is a simplified Prometheus, because you don't have to maintain it, right? As a user, somebody else is
Um,
taking care of that.
does it?
Uh,
Do you use PromQL?
yeah, of course, yeah, Prometheus, yeah.
I, there's no of course in my lands because I don't know any. This complexity is hidden from users. Okay. They just
Yeah,
have an API and PromQL, and that's it.
yeah. You just use the API. So I think that's important, because people come to Cortex and they think they have to learn all of this. I
Uh
mean,
huh.
it's nice and easy, but it just works. And at the end, you don't have to touch it. You just have to configure it once, and once it gets configured, you don't have to touch it anymore. That's
Okay.
Yeah. And from the operation perspective, if you
Uh
want to
huh.
run Cortex for other teams and things, yeah, you do have to, watch the whole thing, and but we do provide like, um, alerts and dashboards for Cortex to monitor Cortex. And also, if you want to try Cortex, one of my teammates in Cortex team created a getting started that is really easy to use. Like, just have to, it's a Docker Compose file
Uh
you
huh.
can run in your machine, and it just set up everything locally for you. So I sent you the link before.
Okay,
It's
I'll
just
put it.
it's the one that says getting started. So you can put it in the chat for people to try
Okay.
it out. Um, and yeah,
We have a nice comment from Ganatech that they like the way we explain this. Thank you, Ganatech. And then here's that getting started link if you want to try it out. Operation view, complexity and control. Those two things go together. Awesome. And then Koramaju says they're enlightened and said, Cortex is horizontally scalable, highly available, multi-tenant, long-term Prometheus. Metrics, for metrics. Thank you. Do you feel like we covered everything? Is there anything else you want to say?
no, I think we covered pretty much everything. Yeah.
Okay. So now that we've gone over the basics, I'm really happy with this board. I like the drawings too. I'm going to do a recap and repeat back to you everything you just taught to me. And I love this part. So here we go. We're just going to do it. And also this is a chance for those of you in chat, this is your last chance to ask your questions live. But we will tell you how to reach the community at the end if you have questions and you're watching the recording. So here we go. So first, to understand Cortex, we first have to understand Prometheus. So Prometheus is ubiquitous. It's a tool that collects and stores metrics. So it allows you to query those metrics and to create alerts with those metrics using their language called PromQL. However, Prometheus has some shortcomings. Those shortcomings are, Prometheus is designed to run on a single machine. So when you have lots of instances of Prometheus, which can be common, it's difficult to access metrics across machines. You need to know what machine it's stored on. You can do highly available Prometheus, but it's not elegant. You just have different Prometheus instances scrape the same data. And then you have to figure out how to manage that duplicated data. In regular Prometheus, different teams share those Prometheus instances. And you have a case where one team can use too many resources, or perhaps teams can see each other's metrics. It can be slow in Prometheus just to query super duper large amounts of data. It's difficult to manage all the Prometheus instances as a whole. And then it also doesn't have long-term storage in Prometheus. So those are some shortcomings. And then we have our hero. Cortex comes and saves the day. So Cortex is multi-tenant, highly available, horizontally scalable, long-term storage solution for metrics, and that builds on top of Prometheus. So a quick note on what metrics are. Metrics are numerical data at a point in time. They're especially about known unknowns, and they're cost effective when used correctly. A very important caveat. So then we talked about how Cortex works. So this is, so we have, first of all, we have the distributor that's stateless and scalable based on hash rings, but we'll talk about that later. And there can be many, and it probably are many distributors. But our distributor is the one that receives the data, and it receives it from one of three sources, either from Prometheus, or from an OTel collector, an OpenTelemetry collector, or from an OpenTelemetry OTLP instrumented application. Regardless, it receives the data, say the data is a blue star, then it will give that data to 3 ingestors. So it's duplicated 3 times. So the ingestors keep the local data for 12 hours, keep these blue stars, but so it gets the data, it stores it locally, it keeps it locally for 12 hours, so it's fast to query for those 12 hours. But periodically, you said about every 2 hours, it takes the data and sends it to object storage. Usually you said S3 bucket. And so that's why it looks like a bucket in the drawing. So when object storage gets the data, there are now 3 copies of the data in object storage. And then that's where our compactor comes in. So our compactor deduplicates the data, so it's down to just 1 blue star in object storage. And it also compresses that object storage into bigger and bigger blocks. So talking about how Prometheus isn't great for long-term storage, this helps save money when things are stored in a long-term way. And that's an overview. So it's highly available because we have our data in at least 3 different places for 12 hours, and then it's up to you to duplicate it across your object storage. It's horizontally scalable because it's easy to scale these distributors because they're stateless, and they're stateless because they use hashing rings. So a hashing ring is an algorithm. So when the distributor receives data, the hashing ring is what assigns it to a specific ingester based on index and labels. And that's how the distributor and the querier also know where to find that data later. And then long-term storage solutions, we'll talk more about high availability. And the long-term comes into play here, and we'll talk more. But now we have the data. It's all over the place. Some of it's short-term on an ingester, some of it's long-term in object storage, and now we have the querier. How do we get at that data? So the querier, it will query, it knows if the data that you're looking for is younger than 12 hours old, it's going to look for it on the ingesters, and it knows where to look because of the hashing ring algorithm. If your data is older than 12 hours, it's going to look in the object storage for that data. It does not have a UI. The client view is that it's just an API that's queryable. All this complexity is totally hidden from whoever's using it. So you don't need to know how old or young your data is. You just ask for what you want, and the querier does the work of knowing where it is. It also has a caching layer, so it's faster to query stuff that you've looked at recently. And just like the distributor, because it's using the hashing ring to know where the data is, the querier itself is stateless and easy to scale. Stateless and scalable, horizontally scalable. So high availability in Cortex. Cortex can be configured to tolerate using an entire availability zone, so geo-replication is possible. And then at a single ingester failure, since it's stored across 3 instances, a single ingester failure is totally no big deal. Like, you don't even have to know it ever happened. Like, it recovers easily. You don't need to perform any manual remediation. Don't even think about it. Don't even worry. And then as far as multi-tenancy of Cortex, this is a use case where Cortex really shines. So you have some way to give identity to your metrics. You're going to use your own identity system and provider for that because Cortex doesn't need to reinvent the wheel. But once that identity gets attached to the metrics, now Cortex can help you implement limits per tenant. So that could be either query limits or ingestion limits. And it also isolates data between teams, so different teams can't see each other's metrics. And then I asked about Cortex and Thanos, because we just had a Thanos episode last week, and it does seem pretty similar technologies. And I do all these hearts because Cortex and Thanos are buddies. Cortex does use some Thanos internally and contributes back to Thanos what they learn and use. If you've outgrown Prometheus alone and you're ready to upgrade to Cortex or Thanos, Cortex really shines in a multi-tenant use case. Thanos has a little bit of this, but Cortex has had it for a long time and it's more mature. Cortex also does really well with auto scaling. You don't have to configure new instances as you add them. It does that the auto configures on its own. Thanos, on the other hand, if you already have a really big Prometheus estate, Thanos is easy to add on top of that and not mess with the Prometheus you already have. So that's when Thanos is a good choice. And the only other thing I think is that we talked about the client view being super duper easy and hiding all this complexity, but there's also an operations view. If you want the control and the complexity, you have an operations view with a dashboard and alerting opportunities. Is there anything else you'd like to say?
Oh, yeah, that was a lot, but yeah, definitely, I think we covered everything. Thank you.
Thank you. Wonderful. Cool. And no more questions came in while that happened, so we're going to say goodbye. To say goodbye, the way this goes is I'm going to replay the music and say thank you to everybody. Thank you Friedrich, for being an amazing guest. Yeah, and sharing your knowledge with us. Thanks everyone who hung out in chat and asked good questions. I appreciate you. And thanks to those of you who watched the recording. Oh, one thing we said we were going to say is how to reach out with questions. If you're watching the recording and you want to say hi to the Thanos, Cortex community, where do you go?
What?
We're still live. Where do we go to ask questions from here?
Oh, that would be the CNCF Slack channel. We have a
CNCF? Cortex.
Excellent.
CNCF Slack channel with Cortex. #Cortex. Thank you. Goodbye. Thanks, everybody.